calculate the area between the two curves. So this was the question that we dealt with. We sketched the graph, but let's just redo this here quickly. Calculate the area between the two curves. So we got x is equal to the square root of 6y, and y is equal to the square root of 6x. Alright, so now, here you got x is equal to the square root of 6y. So remember that this is an unusual type of equation where you have a square root, you're unfamiliar with it. Right, so you need to get it into a form that you're familiar with. Right. So if you square both sides, if I square both sides, so now I have x squared is equal to 6y. So x squared over 6 is equal to y. Right, so now this is not the original equation, but you have an idea of what type of graph it is. See, that's the whole idea. Squared, so you know it's an x squared, it's a parabola, but we will refer to the original equation when we are sketching it. This is just to give us an idea. What about this one? I got y is equal to the square root of 6x, and if I square both sides, then I will have y squared is equal to 6x. So therefore, if I make x the subject of the formula, so then x is going to equal to y squared divided by 6, which is the same as 1 over 6 y squared. Right, so now we got two parabolas. Right, so if you remember, if you recall, if you have y is equal to ax squared, and then we have x is equal to ay squared. Okay, so let's look at these type of parabolas. That's what you need to remember. If you got y is equal to ax squared, and we are dealing with a situation where a is positive. Alright, when I say a is positive, I mean the coefficient of y squared here is positive. The coefficient here, 1 over 6, the coefficient of x squared is positive. Then this is the graph that you get for y is equal to ax squared. And this is the graph you get for x is equal to ay squared. So these graphs turn at the origin. Okay. And then if a is negative, then this graph will be facing down, this graph will be pointing to the left. Okay, but that is not the case. Right, so now. Right, so y is equal to ax squared. This is y is equal to ax squared. X is equal to ay squared. There's my x is equal to ay squared. Okay, but now, so this is the full parabola. But now, let's have a look at the graphs that we're going to be sketching. Right, so let's take this one. Right, so y is equal to not half, 1 over 6x squared. Okay, so you know that y is equal to ax squared. I'm looking at this, and this will be your graph. Okay, this is not the original equation, but this will be your graph. Now let's take a look at this here. This is the graph of y is equal to 1 over 6 x squared. But now, this was the original equation. Okay, let's have a look at the original equation. So the original was given to you x is equal to the square root of 6y. Now, how do we understand what's going on here? We have a square root. Okay, so you cannot have a square root of a negative. So we know that everything inside here must be 0 or positive. That means the y value will always be positive. Now look at the sign outside here. What sign is this that you cannot see? It's a positive sign. That means x can only be positive. X cannot be negative. So here x is positive and negative, so therefore this will be out. Okay. So this is not the original equation, but it just guides us. Right. This is the original equation. X is equal to the square root of 6y. X can only be positive. What about the other one? The other one here is x is equal to half y squared. So x is equal to ay squared. So if I sketch the full parabola, this is how it's going to look. So here I've got x is equal to 1 over 6 y squared, but this is not the original equation. What was the original equation there? It was y is equal to square root 6x. Okay. So remember, this is not original, but this is the original. Okay. So go back to the original equation. Check. We got a square root. We can only have positive, a positive number for a square root. The result here. So x can only be positive. Right, we know that. Now what you need to take note of is the sign outside here. Okay, y is positive. So you got a positive square root. So that means here is the positive y values, here are the negative y values. So y can only be positive, y cannot be negative, erase this here. This is out. Right, so that's how we sketch our parabolas. Right, so if it's unfamiliar, manipulate the equation, get it into a familiar form. Now, what do we notice? We have points of intersection. We already know that these parabolas, well, they turn at 0, 0, so we already have 1 point, 0, 0. We need to find the other point. So there is your other point. So what do we do? For points of intersection, we solve simultaneously. Okay, so we solve simultaneous equations. Alright, so let's deal with those points of intersection. Alright, so let's take our two equations. What do we have? X is equal to the square root of 6y and y is equal to the square root of 6x. So it's up to you now what you want to do. You can take one equation, substitute into the other. So let me take equation 2, substitute into equation 1. So I've got x is equal to the square root of 6 times y. But what is y? Y is the square root of 6x. So now, I've got x is equal to the square root of 6 times the square root of 6x. Don't get confused. Okay, if you have the square roots, how do you get rid of the square root? You will square both sides. So if I square both sides, let's see what happens. If I square both sides, I have x squared is equal to, you square the square root, that will be out. Okay, so what's left is what's inside the square root there, which is 6 times square root of 6. We still have a problem, we have another square root there. Can you say that? So let's square it again. So I'm squaring it. Why? Because I want to get rid of the square root. So now I'm going to have x to the power 2 times 2, that's 4. Here, if I square this, remember this is multiplication, I'll have to square 6 and I'll have to square the square root of 6x. So 6 squared will be 36 multiplied by the square root of 6x all squared will be 6x. Remember multiplication. So now what do we have? X to the power 4 is equal to 36 times 6, which is, what do you get? 216. 216x. Now we need to solve for x. So when you're solving for x, make your equation equal to 0. Do not divide by your variable x. Make the equation equal to 0. So x to the power 4 minus 216x is equal to 0. Factorizer. What do you notice? X and x is common. So take out a common factor of x. What am I left with? X to the power 3 minus 216. Now, all I have to do is equate both factors to 0. So x is equal to 0, or x cubed minus 216 is equal to 0. X is equal to 0, we already know that. This is just confirming what we already know. Okay, x is equal to 0. This is what we need to find, the other part, the other point of intersection. So x cubed minus 216 is equal to 0. So x cubed is equal to 216. I need to solve for x. That's x to the power 3. So what will I do? I need to get rid of the power 3. So I'll find the cube root of both sides. If it's a square, I'll find the square root. If it's a cube, I'll find the cube roots. So the cube root of x cubed is equal to the cube root of 216. So the cube root of x cubed is x, and the cube root of 216 is 6. So finally we found that x is equal to 6. Let's put it in our diagram. So now we need to find the corresponding y value. So when x is equal to 6, substitute into any one of the original equations. In fact, you should be substituting into both. Okay, so y is equal to, I know that y is equal to, there's a here, the square root of 6x. I know that when x is equal to 6, y is equal to the square root of 6 times 6, which is the square root of 36, which is 6 again. Alright, so now we found those points of intersection. Now we need to work out the area. Alright, so we found the points of intersection 0, 0, 6 and 6. Now, we can identify this area between those 2 points. Okay, so here is the enclosed area. So this is the area bounded by the 2 curves. That is the enclosed area. What we need to do is we need to draw our representative rectangle inside that area. So our representative rectangle, we have a choice. You always have a choice unless you are told to use a specific rectangle. So your choice is either using this type of rectangle, where the longer side is the vertical side, or this type of rectangle, where the longer side is the horizontal side. Okay. Now, let's go with number 1 first. Right, let's go with that one. So if I have to draw my representative rectangle inside, here is it. I'm choosing the first option there, so that's there, 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 and there. So there is my representative rectangle. Now, if you draw this type of representative rectangle, now we need to know what is the length and what is the breadth of it. So, from here to here, or from here to there, the longest side, this is the length. So the length is from here to here, and the breadth is here. That's the length, and that's the breadth. Okay. Now, the length is the difference in the two y values. The breadth is the difference in the two x values. So, let's call the top y2, the bottom y1. Okay, so what I'm going to do is, I'm going to the diagram, and I will call the top y2, the bottom y1. It doesn't matter if you wanted to call the top y1, it's up to you. Now, why am I doing that? Because I want to work out the length, which will be the difference between the two y values. Okay, so now, here is your rectangle. So if I want the length here is your length. Your length will be the top y value, subtract the bottom y value. So that will be y2 minus y1. Then your breadth is the difference between the two x values, which is called delta x. That's a change in the x values. Okay. So when we integrate, delta x becomes smaller and smaller, and we get an infinite number of areas. Now, we must show this on the diagram. Here is your delta x. Now, we know that area is equal to length times breadth or width. Now, you need to write down, compulsory step, the area of the representative rectangle. That's just one representative rectangle or strip or element. It's up to you what you want to call it. And this is how you will write. You will write down delta A. So delta A refers to the area of just one representative rectangle. Your length of this rectangle is y2 minus y1. The breadth of this rectangle is delta x. This is a compulsory step. You must write this down. Now, you will write down the total area formula. So once you write down total area, then it's just A. You don't write down delta now, it's just A for area. As soon as you write down A for area, you put your integration sign in. As soon as you put your integration symbol, then delta x now must be written as dx. We are now integrating with respect to x. Okay, and then what do we have here? We have our y2 minus y1. And now, where are we integrating from? Okay, so now you go back to your diagram. This is dx. We are integrating with respect to x. So therefore, we need to identify the x value at the beginning of the area and the x value at the end of the area. That's what you must identify. So there, the area begins at this point. The smaller x value at this point is 0 compared to the end. The end is at 6. So when you are dealing with dx, you check extreme left and extreme right of that area, the enclosed area. Right, so we call it B and A in general, referring to the x values. Right, now comes the substitution. Okay, we are integrating with respect to x. That means we need to get y2 in terms of x. We need to get y1 in terms of x. We cannot have the variable y Yeah, we are integrating with respect to x. So what is y2? Now go to your diagram. We did not label our graphs. Okay, you must label your graph. So let's go and label the graph. So this graph here, okay, this graph here I called y2. Which one is this graph here? This is the graph y is equal to square root of 6x. Okay, so let's just write that down. This is the graph y is equal to square root of 6x. And this graph, this one here is x is equal to the square root of 6y. Now, so you must label your graph so you know that this is y2, that's your top graph, and this is y1, the bottom graph. Okay, so that is your top, and this is the bottom. Now let's check. y2 is already in terms of x there. y2 is the subject of the formula, so we can go and substitute straight away. Now y2 is the square root of 6x minus y1 is this graph here. So I need to make y1 the subject of the formula. You're clear with that? You need to get y1 in terms of x. So which one is y1? It's x is equal to the square root of 6y. This is your y1. So we need to make y1 the subject, square both sides, which we've already done before. X squared is equal to 6y. So x squared over 6 is equal to y1. So there's it here. 1 over 6 times x squared dx. Our values, which we've already discussed, a and b. So a refers to the smaller x value, b refers to the larger one. So the smaller x value, there's your a here, and there's your b. So that's your 0, 6, and now the integration. Okay, so we need to integrate. So term 2, term 1, same type of integration, or this term 1 can be done in 2 different ways. Okay. So a common mistake here is with this term 1, because of the 6 in front of the x, students always make a mistake here, right, with this. So you could simplify first. Let me do the simplification method first. So if I want to simplify this using my exponent laws, this can be written as square root 6 multiplied by square root x. You need to get rid of that 6 there. Now you got x to the power half alone here. Here this is 1 over 6 x squared dx. So you simplify first. Now we can integrate. Square root of x is what? The square root of x is x to the power half. Right, so it's in standard form. Standard form, we can now integrate. So that's going to be square root of 6 times x to the power half plus 1, which is going to be 3 over 2, all divided by 3 over 2. And then we got our minus 1 over 6 x. And then we're integrating 2 plus 1. That will be 3 over 3. Substituting our 6 and then 0. Now you don't have to go and write down the whole thing. We're substituting 6. You know we've done the definite integral now. You're familiar with the calculator. So give me the answer there quickly. When you substitute 6, what do you get? Alright, so substituting 6 into everything here, we get 12 minus, substitute 0. Well, you can see 0 to the power anything is 0. That will be a 0 times anything is 0. So when you substitute 0, you're getting 0. Right. So therefore the answer is going to be 12 units squared. Alright, now just going back to this term here. So alternate integration technique. Let's take this term, integrating the square root of 6x. So as I said, this is a common error. Every time this question comes up, 90% of the students make a mistake by forgetting to simplify. However, there is the other technique, exact derivatives. So here, this is in the form k f of x to the power n multiplied by f prime x. Okay, so this is in the form 6x to the power half. There you can write it. We know if you have an exact derivative here, then the answer is going to be k f of x to the power n plus 1 over n plus 1 plus c. So we've been doing it all along with the more difficult examples. Why not do it here too with a simple example? We can do it by inspection. You can let u equal to 6x, or you can do it by, that is substitution. Let u equal to 6x, or by inspection, which is what I'm going to do now. So inspection, f of x, f prime x, derivative of 6x is 6, cancel it, k, 1 over 6. Can you say that? 1 over 6 and 6 cancel each other out. We're not changing the question. We created the perfect exact derivative. So now all you do is you go 1 over 6, and that will be 6x. Half plus 1 will be 3 over 2, 3 over 2 plus c. So you could have done it this way instead of splitting up. Both are correct. You must come to the same answer. Right, so that was the first one. Let's deal with the next example. Alright, so the next question. Calculate the area in the first quadrant of the ellipse. X squared over 16 plus y squared over 9 is equal to 1. Now, let me refresh your memory on the graph. How does it look? Okay. So we have an ellipse. Like an oval shape. It looks like a circle, but it's not. We have A minus A, your x-intercepts, B minus B, your y-intercepts. So the ellipse, the equation of the ellipse is x squared over A squared plus y squared over B squared is equal to 1. That's your ellipse. If you see a plus sign in between x squared and y squared on one side of the equation, and if you have a number on the other side, it could be an ellipse or it could be a circle. You need to check. Right, so now, how do you check? Check if it has a radius or not. There is no one radius here. The x-intercepts are different from the y-intercepts. Okay. If the x-intercepts and the y-intercepts are all equal, then it will not be an ellipse, it will be a circle. Right, so how do we do that? Let's work it out. You can rewrite this in standard form and just read off the equation, but I prefer to work it out. Okay, so now, if I want to work out the x-intercepts, you let y equal to 0. So let's do it here. So I'm going to have x squared over 16 plus some y squared, which is 0 squared over 9 is equal to 1. Okay, So now 0 squared is 0, 0 divided by anything is 0. So what do we have? We just have x squared over 16 is equal to 1. Multiply by 16 on both sides. So x squared is equal to 16. Now solve for x. That's a square. So let's find the square root of both sides. And when you are finding the square root, it's plus or minus. Remember that? So it's plus or minus 4. So what does that mean now? It means this is a 4 and that's minus 4. Simple thing to do. Right, it's nothing complicated here, the ellipse. So x is equal to plus or minus 4. Now for your y-intercepts. Let x equal to 0. So go back to the original equation. Replace x with 0. So that's 0 squared over 16 plus y squared over 9 is equal to 1. So 0 squared is 0. 0 divided by anything is 0. So I'm left with just y squared over 9 is equal to 1. Solve for y squared first. Multiply by 9 on both sides. So y squared is equal to 9. Y is equal to plus or minus the square root of 9, which is plus or minus 3. So what does that mean? That's a plus 3. That's a minus 3. Simple. Work it out. You can do it a faster way by rewriting this in standard form, but I prefer this way. You will not go wrong. You cannot go wrong if you're working out x-intercepts, y-intercepts. Okay. So let's sketch our graph. So there is your ellipse. That is the full ellipse. So what do we know? That this is the origin 0, 0. Label your coordinates. Label the x-intercepts, but label them as coordinates. Okay, what do I mean now? We got 4 and minus 4. So that's a 4. Don't write it as just 4. Label what is the x value there and what is the y value. On the x-axis, y is equal to 0, and here this will be minus 4 and 0. Those are the x-intercepts. Right. Y-intercepts were plus 3 minus 3, so that was a 0, 3, 0, minus 3. It's best to label them as coordinates. Now, the area in the first quadrant. So here is the first quadrant. We are only interested in that area in the first quadrant. Okay. So let's draw our representative rectangle. That's what we need to do here. So here is my representative rectangle. I'm just going with delta x again. Okay, I'm going to come to an example where I deal with the other one. So you know that if you're using this type of rectangle, where the length is your vertical side, the longer side, then you label the top as y2, the bottom as y1. Or the top as y1, bottom as y2, doesn't really make a difference. Right, now, so nothing difficult so far. We found it's easy to find the x-intercepts and y-intercepts. You got your graph, you identified the area in the first quadrant, and you can see where does this area begin, where does it end. If we're talking about x values, it begins at an x value of 0 and it ends at an x value of 4. If you're talking about y values, then we're talking about the bottom and the top. So that means it begins at a y value of 0 and ends at a y value of 3. Right, but at this moment, we are only interested in the x values because we are using delta x. Right, so now, here is your delta x. So that is your y2, y1 there. Okay. Now, area is equal to length times breadth. That is a formula for area. So now we're going to go delta A. My length is y2 minus y1, and my breadth here is delta. Your length is always the difference between the two y values if you're using this rectangle. Right. Now, total area A, we're integrating, you know, that's y2 minus y1. As soon as I put in my integration sign, then delta x becomes dx, and then we're integrating, that's A and B. Right, now, go to your diagram. Check what's touching the top, what's touching the bottom. That is the main thing. So what is touching the top is, when I say what's touching the top of the rectangle is the curve, is the actual curve y2. Can you say that? What's touching the bottom is the x-axis. Right, so we'll deal with that. The top y2. So what do we need to do now? What do we need to do? We need to go back to the original equation. And make y the subject of the formula, because this is not y squared, this is just y. Right, so what you need to do now is manipulate that equation. Let me give you 2 minutes to try and manipulate this equation. Make y2 the subject of the formula, so we can substitute here and then we can integrate. Right, so what we want to do is we need to manipulate that equation. We need to make y the subject of the formula. So let's do it here. Right, so if we want to make y the subject of the formula, we first need to make y squared the subject of the formula. Right, so where is y squared? Y squared is part of the fraction y squared over 9. That means you need to make the fraction y squared over 9 the subject of the formula first, then y squared second, and then y third, in that order. Okay, so we got y squared over 9 is equal to 1 minus x squared over 16. Now, here, find an LCD first. That is the best way to do this. Find an LCD, so that will be 16 minus x squared over 16. Can you see that? Now you have a fraction on the right, fraction on the left. Multiply by 9 on both sides. So y squared is equal to 9 multiplied by 16 minus x squared, all divided by 16. So let's see what I have here now. So I have y squared is equal to 9 over 16, and that's 16 minus x squared. The reason for the LCD, the reason why I'm saying this is the best way, you must find the LCD, is because you want the coefficient of x squared to be 1 there. You don't want any other number here. When it comes to the integration, you will understand what I'm talking about. Right, which is in 2 minutes. So now, we got y squared. We need to find y, because this is not y squared, this is just y. So now I will find the square roots of both sides. So remember, when you're finding the square roots, you're going to put plus and minus that. So plus or minus the square root of 9 over 16, and that's 16 minus x squared. Now, this is equal to plus or minus. I can now simplify further using my exponent laws. The square root of 9 over 16 times the square root of 16 minus x squared. So that's plus or minus the square root of 9 is 3. The square root of 16, 4. The square root of 16 minus x squared is the square root of 16 minus x squared. There is nothing we can do there. So be careful. There's a minus sign separating the terms. We cannot apply any exponent laws. Right. Exponent laws only works for multiplication and division, not for addition and subtraction. Now, notice we got both plus or minus. That refers to the full graph. But we are not interested in the full graph. We are only interested in this part here. So therefore, because it exists on the positive side of the y-axis, so therefore we will only take the positive part here. Right. So now let's do the substitution. y2 is 3 over 4 times the square root of 16 minus x squared minus y1. Now that is y2, it's touching the curve. y1 is touching the x-axis, and on the x-axis y is equal to 0. Clear with that? I'm talking about here, this y1. y1 is touching the x-axis, which is 0. What are the values that we are going to be using to integrate? We are using the x value at the beginning, the x value at the end, so that's 0, 2, 4. Now you're going to see why I told you to find the LCD, why finding the LCD is the best way to manipulate this equation. It's because now we need to integrate this. How do we integrate something like this? Can I let you equal to 16 minus x squared? Will the derivative, is there any x for it to cancel here? No. So your substitution fails. There is no exact derivative. Is this multiplication? Are there two different variables here? I mean, two different functions of x? No. So this is not integration by parts. This is trigonometric substitution. Okay. So this is trigonometric substitution. So you must be familiar with your trig substitution. We are not going to do it the long way. We will do it by applying the relevant formula. So this is what you are looking for. A squared minus x squared. And on the N5 formula sheet, they do not give you the formula like in the N6 formula sheet. So the coefficient must always be 1 here in the N5 examples. Okay, that's why it is very important to find the LCD, so the coefficient of x squared here is just 1. Right. So now, you go to a formula sheet, and this is a squared over 2 inverse sine x over a plus x over 2 times the square root of a squared minus x squared plus c. Right, so that is the formula, and it was not given to you in the latest exam. I think it was a 2020 exam. So you would have to use differentiation, understand the differentiation part. It's given to you under differentiation but not under integration. So it's best to know it. Let's do the substitution now. So this 3 over 4, I'm going to leave it on the outside. Okay, 3 over 4 on the outside, because I will just multiply my final answer by 3 over 4. So 16 is the same as 4 squared, and then we got x squared. So a squared, that's 4 squared, x squared is x squared. A is 4, that's the main thing. Can you see that? Now, that's going to be a squared over 2 inverse sine x over a, which is x over 4, plus x over 2 times the square root of a squared, which is 16 minus x squared, substituting 4 and 0. Right. So we're going to substitute 4 first. Calculator in radians here. Remember that. So this will be calculator in radians. We're dealing with trigonometry. The angle, that's 4, not 4 degrees. It's just 4. So 4 is in radians. Remember that. Okay. So I'm going to substitute. You can do it on your calculator there. You substitute 4 here. Okay. So I'm just going to work it out without a calculator because I know my trig graphs and special angles. Right, so I know 4 over 4 is 1. Inverse sine of 1 is 90 degrees, which is pi over 2. 4 squared is 16 divided by 2, which is 8. So you're going to get 8 times pi over 2 here. If I substitute 4 here, 4 squared is 16. 16 minus 16 is 0. So that my first substitution, this is what I get. Minus, if I put 0 everywhere here, I know I'm going to get a 0 because inverse sine of 0 is 0. You double check on the calculator. So 8 divided by 2 is 4, so I get 4 pi. So now 4 and 4 cancel. My answer is just 3 pi units squared. That is basically the final answer. Give me 3 pi on the calculator there. Round it up to 3 decimal places. It is 9, 425 units squared. So you can see that when we're dealing with area, you have to know all the different types of integration. We move on to the next example. And our next example, the area bounded by the curve x multiplied by y is equal to 10. The lines y is equal to 1, y is equal to 5, and the y-axis. Right. These are simple things. These are 2 straight lines. Let's focus on the actual graph. Right, so let's refresh your memory from N4 or even N3. We got x multiplied by y is equal to a number. So k will be a number, a constant. You call it a constant, a number. Now, if this is the equation that you have, then there's 2 possibilities. One is where k is positive. The other one is where k is negative. Right, so this is called the hyperbola. Right, so that is your hyperbola, the name of the graph. Now, x multiplied by y is equal to a number. If that number is positive, then the graph will exist in the first quadrant and the third quadrant. Okay. If that number is negative, then your graph will be in the second quadrant and fourth quadrant. Okay, you notice the graph does not touch the x-axis or the y-axis, because if you have to go and make x the subject of the formula or y the subject of the formula, let's see what happens. Okay, let's write it down here. If I got y is equal to k over x, or I can go x is equal to k over y. Now we have a fraction here. Can you see that? We have a fraction, and we know that when you have a fraction, the denominator must not equal to 0. So we know that x must not equal to 0. We know that y must also not equal to 0. So that means you have an asymptote there. It's undefined basically at x equal to 0 and y equal to 0. So the y-axis becomes an asymptote. The x-axis is also an asymptote. Basically, the y-axis is called the vertical asymptotes, and the x-axis is the horizontal asymptotes. But what do you need to remember? The main thing is the curves. If it's positive, quadrant 1 and 3, negative 2 and 4. Right, so now let's see what we're dealing with. So we got x multiplied by y is equal to 10. Obviously 10 is a positive number, so this is the graph that we're going to be sketching. You can use a table if you want to get values, but it's just a rough sketch. So this is the main thing. Let me just show you. So you got your xy axis. You know that this is a positive number. So your graph will be in the first quadrant and the third quadrant. Right, now, what else do we have here? The lines y is equal to 1. Okay, so if y is the subject of the formula, it is a horizontal line. So you take your ruler and you draw a straight line. Here's y equal to 1. What else? Also the line y is equal to 5. So y is equal to 5, maybe somewhere around here. So basically this part of the hyperbola is not required for this question. Right, why? Because it does not fall under the bounded or enclosed area. You can see that. And it is not bounded. So the enclosed area is in between. You count how many things are we in between. So that's 1, 2, 3, 4. The y-axis is also a graph. It's a straight line. Okay, the y-axis is a straight line, and the equation of the y-axis is x equals to 0. It's a vertical line, yes.
So if I'm given extra lines like negative 2 and negative 3,
yes,
will I calculate 2 areas?
Exactly. So his question was, if you had extra lines, we're coming to that where we're going to deal with 2 areas. In fact, I'm going to deal with 2 areas here, you see. If I had another line here, and then I'll have another area. Okay, but that is not the case. Right. So we just have our enclosed area, which is this part here, you can see. So there is your area here. Right, so let's redraw this area. Because you now need to make a decision whether to use delta x or delta y. So let me redraw this area so you can see what's going on. So this is a vertical line coming down there. It's a horizontal line, I'm talking about there and there. And there's a vertical line coming there. But then it starts, it's an irregular shape now because the curve is coming there. So we're going there and there and there. So there is the enclosed area, this part here. Can you see that? That is the enclosed area. Okay, now what you need to, it's not very straight, so just make it straight. So now you need to make a choice. Okay. Are we going to use this type of representative rectangle where the length is the vertical side, or this way here? With this example, you're going to learn. Okay, you'll definitely learn which is the better choice and obviously which is the worst choice in the exam. So now, let's go with the bad choice first. Okay, it's better to do the bad choice first, and then you'll appreciate the easier one. I wouldn't say bad choice, it just takes longer, but if you do it the longer way, you'll understand better when we do it the shorter way. So let's go with delta x. Right, so now if I chose a representative rectangle, here with delta x, I need to check now. Remember the area, this is the entire area here. Right, so this is the entire area. So if I draw my representative rectangle here, I need to check what's touching the top, what's touching the bottom. Right. If I draw my representative rectangle anywhere inside here, I can draw it anywhere inside this area. I can draw it here if I want to, here if I want to, here or here. Let's draw it here and see what happens. Now, let's go to our graph. We didn't label our graph, and we'll come back to this here now. Alright, so now let's go to the graph. So what was this line here? It was y is equal to 5. This is y is equal to 1. And this is the graph x, y equal to 10. Okay, so what did I do? I drew my representative rectangle here. So there's my representative rectangle. So I'm talking about this one. Okay, there's my representative rectangle. Now, you check what's touching the top. Let's call this here y2. What's touching the bottom? y1. The question is now, when I work out area is going to be length. The length of this rectangle will be what? Okay, the length of this rectangle here. So if I go area is equal to length times breadth. So now if I want to work out the length of this rectangle, I'll go delta A. Your length, you understand obviously by now, it's a difference between the two y values. So that's going to be y2 minus y1. And then your breadth is the change in x, the delta x. Now, we encounter a problem when we come to this part of here. Because now, what's touching the top here? What's touching the top here? Remember, what did I call? I call this one. I call the top y2. So that's y2. You can see there, this is y2. This one is y1. But then there's another rectangle that I just sketched here now. Can you see that small rectangle there? There's a chair. We got a problem here now. Because I cannot say that the area is y2 minus y1 for the whole thing. Can you see that? Because as soon as I come to this part here, there's a curve. And this is y2, this is y1, but this is not y2 and this is not y1. Can you see that? So let's call this here y3 now. Okay. But the bottom is still y1. It's the same straight line. Can you see that? So if I want to work out the area here, if I go delta A here, then the length of this rectangle is going to be y3 minus y1 times your breadth, which is delta x. So choosing this option, I have to split up the area into two. Why? Because the area exists. The length y2 minus y1 only exists from this point right up to this cutoff. Can you see this point here? There's a rectangle now. Can you see that? If I cut it up here. There's your top, there's your bottom. But now, there's an irregular shape here. Can you see that? There is an irregular shape here, and the top is y3. The bottom is still y1. So, we're splitting up the area into two. That's exactly what we're going to do now. We're splitting up this area into two. So, let's call this part area A. Let's call this part area B, or you can call it area 1, area 2. The main thing is you understand that there are two different areas. Okay. Now, let's deal with area A. So we got two areas. That's the main thing. Two areas. We have area A and area B. Because you can see clearly, according to the rectangles, it has to be split up. So let's start with area A. Right, so area A, we know that area is equal to length times breadth. So we know that delta, I'm just copying down what I wrote here, but I'm writing it down properly now as if you're answering in the exam. So area A, delta A is equal to length. We can see the length is the difference between the two y values, y2 minus y1, and your breadth there is delta x. So if I write down total area formula, I'm integrating, that's B and A, y2 minus y1 dx. I'm ready to calculate area A. Okay. Only problem is I do not know where it ends. Okay, I do not know where it ends here. I know the beginning. I need to know the ending of this area, that point. Okay, which we're going to calculate now. But let's do the substitution first. What is y2? What is y2? What does y2 represent? So you go to a diagram. y2 is touching the top. What is y2? y2 is a straight line. There's y2 here. Can you see that? y2 is 5. You're clear with that? Minus, what is y1? There's y1 here. y1 is just 1. It's just 5 minus 1. Now, so I'm integrating basically 4. Now the question is, where does this area begin? Which is obvious on the xy axis. You can see this point here is obviously 0, 0. So it begins at an x value of 0. But where does it end? It ends at this point here. At this point here. So I know that this is a 0, 0. I know that y is 0 here on the x-axis. The problem is, what is x then? How do I find that? So this is a vertical line cutting off the two areas. Can you all see that? So that means the x value at this point will be the same as the x value at this point here. What is the y value at this point here? y2 is 5. Now you must just think now carefully. Simple. I know the y value at this point here. The question is, can I find the corresponding x value? Yes, because that's a point of intersection now. Can you see that? This is a point of intersection. So, do I have an equation to substitute 5 into? Yes, I do. The red graph here, the curve. Can you see that? So now, what do I know? That x times y is equal to 10. That is the equation of this graph here. Can you see that? Now I want to know at a y value of 5. That means if I substitute 5 here, what is the corresponding x value? So that means x is going to equal to 10 divided by 5, which is equal to 2. So therefore, this is 2 there, 2 there, same thing. X is equal to 2. So that means I'm integrating from 0 to 2. So now I'll integrate 4, simple, which is 4x. Are you clear with that? Substituting 2 and 0. We don't need a calculator now. With the 2 here, 4 times 2 is 8. Minus 4 times 0, 0. So the answer for area A is 8 units squared. Let's check this because this is a regular shape. Notice that this is a regular shape. Can you see that? We can do this without integration. What do I mean? You got your rectangle there. What do I know about the distance from here to here is 2. Can you see that? There's a distance from there to there is 2. What's the distance going up there? 4. It is, where is my mistake here? Sorry. I just realized now. Okay, sorry. I'm talking about this point here, and I went and wrote down x-axis there, which was completely wrong. This is the point 1 there. 1 there. So I realized my mistake now, because I know the distance is 4. But then it can never be a 0. It's 5 minus 1 there. Can you see that? So it's 5 minus 1 here, which is 4. So, when I was saying x-axis, this is not the x-axis. This is the line y is equal to 1. Right, so we got 2, 1 there. And this is the point when x is equal to 0, y is equal to 1. Yeah, that's correct. Now going back to what the point I was making is that this is a rectangle. Can you see that the rectangle? There's the rectangle, yeah? So what is the area of the rectangle? 4 times 2, which is 8. Same thing. Right, so you get 8 units squared. So that is sorted out. Now let's deal with this part here. This area here, area B. So area B. Where does area B begin and where does area B end? Okay, so go to your diagram. It begins at the point where the last one ended. Can you see that? The end is a beginning, basically. Right. So now, what is the x value at this point here? It begins at 2. So I know when I'm integrating, I'm going to have a 2 there. Where does it end? I need to know where it ends. It ends at this point here. There's a point here. Can you see that? So, what is that point? What do we know? What do we know about this point here? There's it. I'm talking about this point. What do we know about the y value at that point? The y value at this point is a straight line. Y is always equal to 1. Right, so that is 1. Now, I want the x value. So this is a point of intersection. Go back to the equation x times y is equal to 10. So x times y is equal to 10. And I know that y is equal to 1. You're clear with that? I'm solving simultaneous equations basically. Right, I know that y is equal to 1. I'm substituting there. So x is equal to 10. So now we know we're integrating from 2 to 10. And let me just write it down properly. The formula is delta A is equal to, so that's delta A length times breadth. What is the length here? It's y3 minus y1. You can see there's at your top minus bottom. y3 minus y1. Your breadth is delta x. So now total area A. And then we got out, okay, let me just write it as B and A, y3 minus y1 dx. Substitute, what did we work out here? 2 and 10. What is y3 now? There's y3. y3 is the curve. That's why you must check your diagram properly. It's your curve. So y3 is the equation x times y is equal to 10. So this is y3. So make y3 the subject of the formula. What will y3 be? 10 over x minus y1. What is y1? y1 is just 1. You are clear with that? y1 is just 1. So now, I got my 10, 2, oh, let me not write down. I can go and integrate straight away now. Can you see that we can integrate it? We go straight and integrate. So you know that 10 over x is the same as 1 over x times 10. Right. So when you are integrating 1 over x, it's going to be ln absolute value of x. Integrate minus 1, that will be minus x. We are substituting, take out your calculator, let's see what we get here. Here's the advanced one, let me double check myself. Yeah? 10 ln x minus x. What are we substituting? It doesn't matter whether it's in degrees or radians, this is not trigonometry. So that's going to be, we're substituting 10 first. We get 13,025,850,93 minus, substituting 2 now, I'm getting 4.93147806. Are you getting the same answer? So we get 8.09437912. That is the area B. So now we want the total area. We want the total area. Now you'll understand that. So therefore, total area will equal to area A plus area B. So there's area A and there's area B. So you add them up to give you your total. Basically, you're just adding h to h there. You can see that. So that will be 16.094 units to the power 2. And that is rounded up to 3 decimal places. That's the correct answer there. So, what just happened here? You made a choice, and because of the choice that you made, you have to split up the area into 2. Not advisable in the exam, but obviously when you're practicing, you must do everything. Now, you're going to see how fast, in about 2 minutes, we'll get the same answer using the other method. Right, so I read through the diagram, same diagram, but this time we are choosing this type of representative rectangle. Okay, so now what does it mean? Let's enlarge this here. So the best thing is to enlarge in whatever area you have, redraw it, so you have a good understanding of what's going on here. There is your area. Right, that is the enclosed area. So what did I do? I'm using this type of representative rectangle, where the longest side is the horizontal side. So if I'm doing that, I'm going to call this x2, and I will call that x1, and the breadth is delta y. Right, so there is my delta y. Let me call this x2, and I'll call that x1, because the length is the difference between the two x values. Right, that is the length. Right, now, you need to check now. Move your representative rectangle. Check if I draw it here, or if I draw it any other place, will there be a difference in what touches the right and what touches the left? That is the question. Okay, so what's touching on the right is x2. What's touching on the left is x1. Even if I sketch it here too, the right will always be x2, the left will always be x1, different from the one that we just did when we're using delta x. Remember that? So therefore, there is no splitting up of this area. All right, so now I'm going to go area is equal to length times breadth. So delta A area, your length there is, you know, when you're doing horizontal, it's right minus left. So it's going to be x2 minus x1 times delta y. Total area. Integrating, since we are using delta y, that means we are interested in the y value. So that's d and c, x2 minus x1. There's my dy. Okay. Now, if I am using delta y, that means I need to check the extreme bottom. What is the y value at the bottom and what is the y value at the top? So let's go to our diagram. What is the y value at the bottom here? It's 1. You can see that? What is the y value at the top? It's 5. That's all. Simple. So that is 5, 1. What is x2? Go to your diagram. What's touching x2 represents the curve. Can you see that? So there's x2 here. Make x2 the subject of the formula. Get it in terms of y. because we are integrating with respect to y. Simple, all you have to do is just divide them. So x2 is equal to 10 over y minus x1. Okay, so on the y-axis, what is x at this point here? It is 0. Okay, so x1 is equal to 0. Now, all we're doing is integrating 10 times 1 over y. So what is the answer going to be? 10 ln absolute value of y, substituting 5 and 1. So we get 10 ln 5 minus 10 ln 1. Ln of 1 is 0. You don't even have to use a calculator there. And then magic happens. One time you get your answer. 16,094 units to the power 2. Can you see that? So the whole idea when you're dealing with area is try not to split up. Don't use a method that's going to split up the area in two unless you are forced to do it. And we continue next time.